I've taken this from your formula sheet at the end of year, so you're going to get it anyway, and some of which you won't need to sort of memorize because you already know it, but some of which you don't. So I'm just going to quickly just do an outline just so you can see, but this is what you're going to be doing. This is what I meant by skills, is that you need to be able to differentiate each and every one of these functions and use the chain rule appropriately. Okay, so let's have a look. The first part, which is what you've learned, x to the power of n, it's a power rule, it's a polynomial. So if I gave you x squared and I said the derivative of that, you're using this rule here. Yeah, it's a power rule. This is technically still a power rule, but you're using a chain rule in it. Derive the inside and then bring out the outside. That's what you're really doing. So derive the inside and then bring down the n, minus the n by 1. That's why they've got n minus 1, and they've got a times n. It's really just a chain rule. So a quick example of what that is let's say I gave you, I don't know, 2x minus 1 all to the power 6. Then, oh, that's pretty ugly. Let's do it like this. 2x minus 1 to the power of 6. Okay, and if I asked you to find the derivative, I will teach you to say find the derivative of the inside, which you would say dy dx equals derive the inside derivative of 2x minus 1, which is 2. Good. So 2 times, and then you bring down the 6. So that's 6 times 2x minus 1 to the power 6 minus 1, 5. Yeah, and that's what this rule is just saying. See, a, which is the derivative or coefficient of x, but the only reason why is because the derivative of x will give you a. Okay, so that's why they have a. Bring down the n and n minus 1. That's what that chain rule is about. Okay, so using chain rule within power rule, so you don't have to memorize the second rule is what I'm trying to say. You only needed a power rule and you need a chain rule, you can get that. Okay? Next one, so that was your first exercise on 9C and the one where I was away yesterday, and that's 9F. So if you had x to the power of a fraction, 3 on 2, it's the same thing. You're still using your power rule and you're saying dy dx equals to negative 3 on 2, x to the power of negative 3 on 2 minus 1. Same thing. Okay, so they're still using power rule. That's why I'm sort of clumping it together and saying that's 9C, 9F. Next one, today's session. GH, you're now working with exponential, and then you're working with log. Okay, now this is the one they give to you in your formula sheet. The reason why I don't like you memorizing these is because in the exam they don't give that to you. Instead they give this to you. They give you that. Okay. Sometimes you can add a few more numbers, but students will look at this and then look at this, and they now go, oh, well, there's a square, but who cares? Let's just pop that down, or maybe they'll just say that means dy dx has to equal to 2e to the power of x squared. I don't know, you guys make up a lot of rules yourselves, but the reason why I don't like teaching it this way or memorizing it from your formulas is because you'll screw up there. And really, all you had to understand was the one rule for exponentials is if you have y equals to e to the power of x, the derivative is itself. Anything that's different to that, you use a chain rule. So for example, that one that I just gave you, the chain rule will be derive the inside and then derive the outside. True? So if I just derive the inside is this. Why I call that the inside is because that's what's changed. That's what makes it hard, because you could do this. If I gave you e to the power of x and I said derivative, you're like, yeah, I know it. It's e to the power of x. The only reason why you can't do it is because now I said it's x squared. So where chain rule applies is you're saying pretend that is x, or pretend that is e to the power of something. So if you derive the inside, derivative of x squared will give you, what does that give you? 2. Derivative of the inside, so dy dx, gives you 2x. Okay? And then you multiply by the derivative of the outside. Now, this is e to the power of x squared. If you pretend that was e to the power of u, or e to the power of x, the derivative of e to the power of x is itself. So I just write e to the power of x squared. And suddenly you're done. 2x e to the power of x squared. See, if you understand it this way, as in you understand derivative of y, or e to the power of x is just itself, then you don't need to memorize this rule. Because why does this rule work? It works because you're just saying this. If I gave you e to the power of 2x, you can use exactly the same method I just showed you. You could say derive the inside, because that's different. That's 2x. We only know x. We don't know 2x. So if you derive the inside right now, that's the only thing that's changed. Derivative of 2x is 2. Okay, so we go, all right, do y dx equals 2 multiplied to derive the entire thing, which is like pretending. You're pretending, you're imagining it's e to the power of x or e to the power of u, which is itself. So that means it's e to the power of 2x. And suddenly, this looks exactly the same as this rule. See, the rule is just saying if you have e to the power of ax, just drop down the a. But the only reason why you can drop down the a is because the derivative of 2x, or any linear, is the coefficient. That's why. Coefficient means the number in front of x. Okay, and so you guys will be able to do this using that rule, but then when you come to the exam, they never do that. They always give you this. And suddenly, students screw up. It's because you're relying on this formula, which you're not understanding why it works. And it's hidden. It's hidden for you that you've learnt this is a chain rule of this. You've learnt this is a chain rule of this for linear power. You could have a quadratic power, you could have a cubic power, we don't know. Okay, so that's what I'm saying, don't rely on the rules, but you just got to remember what you learnt in year 11. Okay, derivative of e to the power of x is itself. The second rule is if you have y equals log e of x, we know the derivative is 1 on x. Okay? And same thing, if you get anything that's different to what you know, this is what you know from year 11, anything different from this, you're going to use chain rule. So let's take an example. Let's say I gave you y equals to, I don't know, let's do log e of 3x squared plus 2. Okay? Looks hard, but it's not. Because the only thing you knew was this. Anything that's different from that, use chain rule. So here, what's different? Instead of x, I now have 3x squared plus 2. So to find the derivative, you're just simply saying, find the derivative of the inside. Okay, so find the derivative of that, which I want to do with you. Let's do it. Do y dx must equal to, now derive 3x squared plus 2. What does that give you? 6x. So I'm like, all right, 6x multiplied to, now you derive the entire thing. But when you derive the entire thing, just pretend what I just highlighted is a letter. Pretend it's log e u. Then the derivative of log e of u must be, yeah, it'll just be itself. It'll just be 1 on u. And so if this is my u, then I can just say, oh, that must be 1 over 3x squared plus 2. See, look at that. So if the derivative log e of x, I've got an x there, it becomes 1 on x. If I have 3x squared plus 2, then the derivative of this must be 1 on 3x squared plus 2. But the only thing I had to add extra was times it by the derivative of the inside, which is 6x. And suddenly you're done. You now got 6x over 3x squared plus 2. And voila. I've just pretty much quickly, briefly, gave you an idea of what 3G and H is about. So what was the concept? The concept was simple. You only got this one rule, plus y equals e to the power of x. Derivative of that is itself. Whatever you learnt in chain rule, you're applying into these two rules there. Okay, so I'm going to show you a couple of examples in the next few pages, slides. We'll show you some of the exam questions, and you'll see you're never going to get these types. The ones you're always going to get are the ones I just made up. The one that normally gets students is when you put a fraction in it. You have a fraction on a fraction. So for example, this one, if I wanted to make this hard, like a year 12 end of year example, I would change it and probably do something like that. Or maybe put a negative. Or if I want to make it a bit harder, I do 3 on x. And suddenly, I'm going to get a lot of students on this one. Because finding the derivative of this, you'll be fine if you bring up the x. But then finding the derivative of the entire thing, it'll be 1 over 3 on x. And that's something that students find very difficult. See that? Something screws them up. Okay, but that's been one of the exams. They make it look simple. And it's a question of, did you understand it's a chain rule? Derive the inside, derive the outside. Okay? And then, if you then move your concept to the next part, this whole entire thing here is 9i, circular functions. So again, you don't need to memorize these rules because they only work for linear functions. Have you noticed that if I just highlight it for you to see, AX is linear, AX is linear, AX is linear. Every formula sheet that you're going to have is always linear. It's not useful. It's not useful in the sense that because the exams aren't going to give you linear. Instead, they're going to give you quadratics, cubics, logs. Okay, they never give you linear. That's why having this formula sheet in the exam means nothing. Because you look at it, and if you don't understand it's a chain rule problem, you screw up. Okay? So what I want you to learn from each and every one of these are these 3 rules. So the first one was, I said, you have y equals e to the power of x, derivative, which I'm going to use y dash now, is itself. I wanted you to know that. That's one rule. That's 9g. I wanted you to know for h, log e of x, the derivative is 1 on x. What I want you to know for 9i is if y equals sine of x, say I'm not using the ax because it changes. You could have ax squared, ax cubed, whatever it is. What I want you to understand is the derivative. We know the gradient for every point on this curve for y equals sine of x is cosine of x. And then y equals cosine of x, derivative is equal to negative sine of x. And then finally, y equals tan of x, the derivative is sec squared of x. Okay? That's what I want you to remember for each and every. That's why I'm saying today's a skills session, because you've learnt this in year 11. Every one of these you've learnt. Now, I'm going to force you to use chain rule, which is the last session. I wanted you to be able to do 9e in every one of them. Because that's the only difference for year 12. Whatever you were in year 11, I could easily have given you a year 12 question by manipulating those x's. Instead of x, 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 I could have changed all that to be x squares, x cubes, log x. What's? Sec squared, by definition, it is 1 sec of x, which means the second, is equivalent to 1 over cosine of x. That's by definition. Okay? So when we say second squared of x, that is the same thing as saying 1 on cos of x squared is what you're really saying. So you're saying 1 on cosine of x, square it, meaning times itself. That's what it means. It's rare that you'll have to do anything further than that. That will probably be more specialist. But at our point, we only need to understand that's what it means. And you can sub in values to work out because you know that whatever cost of the value is, which I'm going to teach you in the second half of the session to memorize your exact values in case some of you didn't learn it last year. Okay? But does that make sense? So what I want you to understand are these, what is that? 1, 2, 3, 4, 5. 5 rules. And in the next few slides, I'm going to get you to practice by using chain rule. I'm going to show you how each one is from a year 11 to a year 12 standard. That's the only difference. Okay? Let's have a look. And chain rule there was 9e, not 9d. And product rule is 9k, is what we're really working on. Okay? 9j, sorry. Actually, that should be 9j, k. K must be the other one then. Yeah. Okay? Here we go. Let's have a look. I'm going to give you, let's look at each and every one of these. It ranges in terms of difficulty, but this is your textbook problem. You're never going to get this in your exam. Okay? If it's exam 1, it's going to be much more difficult. So let's have a look. A. Y equals e to the power of 3x. What I want you to understand is exponential. The only one rule you knew for 9g was e to the power of x, the derivative is itself. That's all you know. So anything that's different to this, use chain rule. Okay, so anything that's different to this, use chain rule. So for example, in our case there, I'm going to highlight what the issue is. The issue is the 3x. So we know x, we don't know 3x. So because that's the issue, you're going to do the chain rule by deriving the inside before you derive the outside. So right, here we go. I'm going to quickly just write down the answer. I want to derive the inside, so do y dx equals derivative of the inside. 3. So it's 3 times, derive the entire thing, so you pretend it's e to the power of something. Derivative of e to the power of something is itself. So this would just be e to the power of 3x. Because you just literally pretend this is just u. So we know from this format, e to the power of u, derivative of it is e to the power of u. But instead of writing u, I'm just going to write it as itself. So it was 3x. So it's just derivative of itself. Because I know it's exponential. Okay, because that's what I said. I said e to the power of 3x, derivative of itself should be itself. Okay? And there you go. I'm done. The derivative has to be 3e 3x. If I carried on, same drill. I'm going to carry on with the same drill here. Let's have a look. Same one with the next one. B. Looks difficult. Not difficult. Because when you're saying y equals e negative 2x, same thing. What is changed? What has changed? What is different than negative 2x? So you don't know what negative 2x is. You knew the derivative of e to the power of x. So, same drill. I am now going to say, find the derivative, whoops, where's the color? I want to find the derivative, dy dx, of the inside. Whoops, my inside was negative 2x. So derivative of negative 2x, or the inside would have to be, what was it again? What's the derivative of negative 2x? Negative 2. So I just write negative 2 times, now you pretend as if this didn't exist, it's just e to the power of something. Now from the rules we know, e to the power of something, if you find the derivative of it, it is itself. So I'm just going to write it, e, and you're done. So even if I change the problem, like all these are exactly the same, if I just wanted to make it more difficult, I can easily do this. I can just put a cube there and make that x squared if I wanted to. Let's say I change that problem. That should not be any different from what I just did with you. It should be exactly the same. Let's try this. Let's try the one I just made up. Okay? Let's change that to 2x cubed plus x squared. Same drill. See, if I were to find the derivative of this in the exam, it should be, what's changed? That power. That's changed. That's different to what you know. So, I'm going to use the chain rule. I'm going to replace this. I'm going to say derive the inside. Now what's the derivative of the inside? 6x squared, good, plus 2x. So I've derived the inside. Now I'm going to do exactly the same. Derive the outside. So times that by the derivative of the outside, which has to be? What is that? Itself. Same thing. So it's just e to the power of 2x cubed plus x squared. Done. How easy is that? But that's your end of year exam 2 marks. Obviously they'll add a couple other things to it, but that's a 2-mark question. 2 out of 40. It's easy. 1 out of 20. Okay? You got your 1 out of 20 or 2 out of 40, and it's a very easy concept. But you can see this is something you learnt in year 11. All I've done is I've applied chain rule to it so that it becomes year 12. But it shouldn't be. I could technically teach that to you in year 11 once you learn chain rule. Yeah? And if you're wondering about the last one, if that confuses you, I know we hate fractions, but you can change every one of them. Anytime you see a fraction when it comes to derivatives, you can bring it to the numerator. You can change this. E to the power 1 on e to the power 2x is the same thing as writing what? Anyone know? What's the same thing as writing as? What's another way of writing 1 on e to the power 2x? Yeah. You change the bottom power, you can change it to a negative, so it becomes e to the power of negative 2x. And suddenly you're back to square one. You've done the derivative of negative, you know how to do that, and you know how to do derivative e to the power 3x. You've done that before too. Do them individually. Was that easy? Hands up if you understand. Very good, that's 9G. Now 9H is exactly the same thing. Let's have a look at 9H. Okay? 9H. I've specifically chosen these ones so that you can see I'm varying it. I'm varying the problem. So again, for 9H, what was the rule? This is the only thing we know. we know y equals log e of x. The derivative for log e of x is what? What was it again? Yeah, 1 on x. 1 over whatever that is. That's an x. That's an x. If that was x squared plus 1, then it becomes 1 on x squared plus 1. Okay? Now, let's have a look at this problem. See, if I did the same thing again, same drill, y equals 2 log e of x squared plus 2, what has changed? See, the only thing we knew was this. So what's changed? X squared plus 2. So that's the issue. Because that's the issue, I'm going to find the derivative of that. This is the issue. So if I replace that, that's what chain rule is. The chain rule is trying to help you figure out the derivative just by making it easier. So they're saying, all right, let's do the quick way. Derive the inside, derive the outside. That's what I'm going to do. So I'm going to say, all right, let's change. This is dy dx. Same drill. Derive the inside, then derive the outside. So let's derive the inside. X squared plus 2. What's the derivative of the inside? 2x. Simple. 2x times, now you pretend as if that doesn't exist and you got log e of something. And the derivative of log e of something has to be 1 over something. Okay, because that's what it is. It says log e of something. The derivative of what it is 1 over whatever that is. So I'm going to write it down. I'm like, all right, so that means the derivative is 1 over x squared plus 2. Because that's the something. I'm just using the rule of what we learned. That was the format. Okay, so I've derived the inside, derived the outside. It's the same drill over and over, just like your exponentials. Yes, Leila? No, definitely not. So you'd rewrite it as 2x on x squared plus 2. Okay, and if you can simplify, you do, but in our case, we can't simplify it, so you leave it as it is. Easy? Let's have a look at the next one. Log e of x all squared. You're like, oh, sir, I don't know how to do this. It looks different to what we had before. No, it's not any different because you could do this one. If I gave you this, if I gave you 3x plus 1 all squared, you had no issues with this. We did this right at the beginning of our session just now. And I said, derive the inside and derive the outside. The only thing they've done is instead of writing 3x plus 1, they wrote log e of x. Ooh, same thing. It's a power rule. It's just something squared. You see, you can do this. If I changed that and I just said x, and I said, what's the derivative of x squared? Every one of you can do it. But as soon as I change it, as soon as I go, oh, here we go, log e of x, suddenly a lot of kids can't do it. It's the same thing. If you could replace that with an x, every one of you can do it. It's the same thing. If anything changes, use the chain rule. Anything that changes, use the chain rule. So in our case, what's the issue? This is the issue. See, if that was x to the power of 2, you're fine. Because that's the issue, now you find the derivative of the inside and then derive the outside. So I'm going to do the same thing. Let's do it again. I'm going to do exactly the same thing. Y equals 2 log e of x all squared. So if I think of it that way, I'm like, all right, derive the inside, then derive the outside. So let's derive the inside first. dy dx must equal to, let's derive the inside. The inside is log e of x. That's the issue. Derivative of log e of x must be 1 on x. That's what we know in our rule. So okay, I'm like, all right, 1 on x. Multiply to, now you pretend that is just a letter. So it could be u squared. What's the derivative of u squared? 2u. So it's 2 times whatever this is. Just like you would have done chain rule. Bring down the 2. Minus the power by 1 using a power rule. And so this now just becomes 2 log e of x, and in our case 2 minus 1, this is to the power of 1, so it doesn't matter, you don't have to write it. Or, normally you would write it, whoops, you can write it like that if you want, it just looks ugly. So log e x to the power of 1 is just log e of x, so you can just remove that and say that. You don't finish there. Finish your answer as 2 log e of x, all on x. Whoops. But are you getting the drill of what I'm trying to do? You see, for every function that you know, for every rule, anything that changes, use a chain rule. That's all they're trying to do. GHIJ, the same thing, same drills. All the way, you're using chain rule for every one of them. Okay? Now, here's your shot. You do this one now. I just want you to find the derivative first, and then if you can find the derivative, find the gradient. But look at that. Does that look hard? Yes, it does. But is it hard? No, it isn't. Have a shot at this. Think about it. You got an exponential. Is it any different from what you've been doing? Let's have a go. I'm going to give you, I reckon, 2 minutes. Find the derivative. Just A. Don't worry about the substitution for now. We're just working on the derivative. Find the gradient. Find the gradient. So I just want you to derive this and then sub in at x equals 0 and find my gradient. Don't forget, derivative gives you the gradient function, gives you the gradient of your tangent lines. Don't ever forget that. It's always to find your gradient. That's what you're doing. All these skills I'm teaching you here is to find the gradient of a tangent line at a particular point. In our case, the point is at 0, 1. Okay? Do the same thing. No different. So just write it bigger so you can see. Y equals e to the power of x squared plus 3x plus 2x. Now everyone can find the derivative of 2x. Your job is to find the derivative of e to the power of x squared plus 3x. I don't care. So you see, if that came up in the exam, you can't use your formula sheet. But if you use what I'm teaching you, you can do it. It's just the one rule. Use the exponential rule and use chain rule. Simple concept. Oh, you got 17. Yeah, it's a 17. Yeah, which diagram did you use? Yeah. Ah, that explains. See, I drew my diagram, A to D, I drew it out here.
You almost did that, but it said on the highway. And they only mentioned the east to west highway.
Oh, is that why?
So you did highlight the right line, but you missed the highway bit.
Ah, highway.
Just to go over the previous question, in your fitness, you will get negative 2e or negative 2x 3x squared. Would you change this and put this 1 over 2 and negative 2x when you're writing your final answer, or is this fine for like final answer?
Right. Yeah, like this.
Right like that?
Yes, but the 2 doesn't go down.
Yeah, so it's 2 over?
Yeah. Alright, let's have a look at your answers. dy dx, same drill. We should know the derivative of 2x over here is 2, so no issues there. Derivative of this. The issue was the x squared plus 3x. Because that's the issue, derive the inside. This is my inside. That's the issue. Because if it was e to the power of x, you had no troubles. But because I changed it to x squared plus 3x, that's what you deal with. So, using the chain rule, you should have got this. Let's go. Derivative of x squared plus 3x is 2x plus 3 multiplied to itself. Because the derivative of the entire thing is itself. So it should just be e to the power of x squared plus 3x. Hands up if you got this. Alright, fantastic, good, I taught you well. Now, to answer the question said at the point 0, 1, that tells me at x equals 1, what I want to know is what is my gradient of the tangent line. That's what it's really asking. Okay, so if I just drew a picture, I'm just saying, when x equals 1, at this point, I want to know what the gradient is. That's your tangent line. Okay, so you've got a tangent line. I just want to know at x equals 1, or 0, sorry. 0. No. X equals 0, and you just want to know what is your gradient at that point. That's what you're really doing. So you just found out the gradient function. Now at x equals to 0, you figure it out. So let's do it. I'm going to sub in 0, you got 2 times 0 plus 3, e to the power of 0 plus 0 plus 2. And that technically gives you what? 3 e to the power of 0 plus 2. And e to the power of 0 is 1. 1 times 3 is 3 plus the 2 is 5. Now, hands up if you got this correct. Hands up if you made a mistake with 3 e to the power of 0 is writing as 1. Okay. There's a difference when you write 3e to the power 0. Remember, it actually means 3 times e to the power of 0. And we know that e to the power of 0 is 1. That's why it's 3 times 1. So be careful with that. That's a common mistake that comes up in the exam. That's why I picked it up. Okay, it's a common mistake. Most students just see a 0 and they're like, oh, it's all equal to 1. Okay? So just read what it actually is saying. Any questions on that? How's that feel? Good? All right. Let's have a look at... Don't worry about it. These are the solutions if you want to look. Let's try this one. I'm going to get you to do C and F. Have a go C and F for me. Same drill. This is 9G, same drill. If you get the drill, you can do H, you can do I, you can do J. It's the same thing. Same drill all over. Okay, let's have a go. C and F. C and F. That's a typical one in an exam. First one is A. That's common. The product rule. Product rule and chain rule. Always in your first questions. That's e to the power of e to the power of x. That's alright. F e to the power of e and x, and C root. Remember, the square root sign is the same thing as to the power of half. I like to do that in the exams. They put in a square root. So remember that. Check your answers. I changed the square root to the power of half, derive the inside, derive the outside. Power rule, drop down the half, minus the power by 1. The last one, e to the power of x times e to the power of e to the power of x. That's got the same bases, and when you multiply with the same bases, you can simplify by adding the powers. So I encourage you to write it like this: e to the power of x plus e to the power of x. Okay, don't leave it like this. Okay, because you can simplify that further. It's like saying 3 squared times 3 to the power of 5. You add the powers together. Same thing. Same bases, add the powers. Okay? Hands up if that was easy. Hands up if that was hard. Hands up if you don't really care. Alright, fair call. Good. Well, I've done my job. That's 9G. Now, let's have a look at, these are the solutions. You can have a look at it afterwards. Is this an exam question? Oh, no, I don't think so. No, it doesn't look like it. No. This is now log. I just want you to find the derivative of this for me. Okay? The next one, don't worry about the next one. You can have a look at that afterwards. Right now I'm just trying to teach skill. Okay? And then we'll have a look at those kind of problems afterwards. It's the same thing. If you can read that, then you can do it. But I just want you to do this one, 5. I'm just going to quickly whip through and get you to practice some of the questions, give you a bit of a break, and then we'll jump into learning exact values. I'm going to teach my way of how you're going to memorize all 15 exact values. And you walk out and you know all your exact values, okay? It takes about 5 minutes. Find the derivative. Same drill. Same drill. This is a double chain rule if you didn't realize. There's 2 chain rules in it. Double chain rule. You're going to chain rule the inside, or you're going to chain rule the outside. Hands up if you're struggling. Hands up if you're finding this easy. Hands up if you think you know what you're doing, but you're unsure if your answer's correct. And the rest is kind of like, I don't want to put up my hands. They're cool. Alright, let's go through this. I said it's a double chain rule because you've got a log e of, and what's inside the log is you've got a square root, which I've done to the power of half, of x squared plus 1. So it's still the same drill. It's log e of something. Okay, so this is my something. To find the derivative, you find the derivative of the inside, which is what I've highlighted. So this is my inside. The problem with the inside is that also requires chain rule to find the derivative. Okay, so let's just find the derivative of this now. Notice I've underlined x squared plus 1 because that's the issue. If I gave you x to the power of half, you would have been able to do it. No issues. But because I gave you x squared plus 1, that now becomes my second issue. So it's inside of inside if you like to think about it. Or, if I use another color, you can think of it as, whoops, chain rule of this first. So derive the inside, then derive the outside. That gives you the overall inside. Okay, that's why I'm saying it's a double chain rule. So if we work this out, let's go. We're going to say, I'm going to change it to red. Derive the inside, x squared plus 1. We know that's 2x multiplied 2. Derive the outside. Okay, that's to the power of half, so drop down the power. Half x squared plus 1. Half minus 1 is negative half. Now that's the derivative of the inside. I've used the chain rule there. See, that's why I've used the chain rule for the inside. Now I've got to derive the outside, which is my log. So I'm going to use another color, so you can see. This is times, derive the outside, that's a log of whatever this is. So, derivative of log is 1 over, whatever that is. So it's 1 over x squared plus 1 to the power of half. Hands up if you got this step at least. Okay, significantly less, but that's okay. Hopefully you're starting to pick up what I'm doing. Now, it's all about simplifying now. So that's negative half, I can drop it all the way down, so it's 2x over 2 root x squared plus 1. And this is times 1 over root x squared plus 1. And nicely, because those are all multiplication, I can cross out the 2's. And now if you multiply root of x squared plus 1 times root of x squared plus 1, gives it x over x squared plus 1. Now who actually got that final answer? Alright, well done. Excellent, good. For those who didn't, look at my steps, check it out, see where you went wrong, where did you misunderstand, fix that, write a note for yourself. Okay, because that is expected. End of year you could easily get something like that. And that's something I want you to look at and go, yes, 2 marks in my pocket. I don't want you to look at it and go, oh, I don't know if I got the 2 marks. Okay, because that's an easy question. It's a very straightforward short answer question. You have to be able to get that 2 marks. Okay? Otherwise, yeah, that's what sets you up above the average, which is 30. Okay, you want to get above 30, that's going to always do better than what the state does. So the state can easily screw up on that. I wouldn't be surprised if that came up in the first one and not everyone gets it right. Okay? Alright, here we go. Next one. Did I have solutions for these? Alright, those are my solutions in case you want to have a look at them. But you can practice that if you want. This is the recap. In the next 15 to 20 minutes from now, I just want you to now go to 9G, 9H. You can try these questions if you want. Okay? Remember, don't do a lot. Study smart. If you get it, you got it. Move on. Okay? I'm just giving you a couple of ideas so that you know what you need to face. And it's just the one concept. Understand the rule, use a chain rule. Okay? 9G, 9H, and then I'll come back and I'll show you exact values, how you can memorize all 15 of them within 5 minutes, and you should all walk out knowing how to do it. Okay? I've successfully done it every year, so you guys can't fail me. Exactly. So like sine of pi in 3, cosine of pi in 2, that kind of thing. Stop the video, and then we'll do another one later.